Okay, okay. Okay, guys. Good lord. Okay, so we're going to be talking about straight lines. And I keep hitting the wrong buttons to get to where I need to go. So, that's smart. Alright. So, an XY axis, or a Cartesian plane, or wherever you call it, is just a way of telling someone where on a sheet of paper a point is. So if I say, hey, my point is at 1, 2, that tells me my x position, and x position controls your left-right movement from the origin, so where you should start. So this says move a distance of 1. We don't really give units for the distances on an XY graph. It's just however big a tick mark is. So it's saying, make sure that you go to the right 1, and then go up 2, and that is where our lovely little point is. That's where on your piece of paper, relative to where your origin is, our desired point is. Now, let's say that we wanted to tell somebody about a group of points that are going to be on our graph, not just one. But that we're going to have a lot of points. Not just, 4 or 5. Thousands of points. Millions of points. A Google number of points on our graph. Well, we can't sit there. I keep hitting my mic. Maybe that's the next thing that I'll do if I ever have the cash, is just, bite the bullet and buy a real mic. Because I'm just using a headphone, a headset microphone, and there's, a whole boat of problems there. So, I can't just sit here and go, okay, well, one of the points that I want to talk about is here, and then the next point is here, and then the other one is this point. Oh, and I have 50,000 more points to write down to tell you where they are on our piece of paper. So, we have math things called functions that are essentially machines that can tell you where all the points that we are interested in writing down are if you ask it a specific x value. So a function that I could have is f of x equals x squared plus 1. This is a way of writing down an infinite number of points on your graph without actually having to list what all the points are. What we have to do is we have to provide it a left-right position. We have to tell it where on our coordinate axes we're interested in, so it makes a little sweep and says, okay, you want me to tell you what points are at this left-right position. You run the numbers, and it's like, okay, this is where that y value is if you give me this x value. So, like, if we wanted to know, hey, where's the y value? What points do I have if I plug in x equals 3? Where would I find a point? Would I find a point here? That's actually a really good idea. Thank you. That's actually a good idea. Like, do I have a point here? Do I have a point here? So the function is going to tell us if we have any points at this x value, and if we do, what the y value is, so we know where the points are. So that's how you can tell that it's a way of listing all the points that you need to graph without actually having to write down, trillions of x and y positions in parentheses with a comma separating them. Okay, so using this function, we can plug in our 3. So we say, hey, do we have any points at x equals 3? And our function's like, heck yeah, we do. Wow, that's a very weird 0. You know something really funny? I didn't even catch the missing E. I was like, yeah, I know what you mean. Okay, so it's like, heck yeah, you have 1 point at x equals 3. It's at x equals 3, y equals 10. There's one of the points that you have on your piece of paper relative to your origin. Right there. So that's essentially what functions do. Indeed. Okay. Straight lines how far back do I need to go? Ah! Alright, fine. Home. File new. It's okay. I have the copy paste function. Why is it doing that? Stop doing that. There we go, okay. Paste. Cool, okay. Straight lines, the equations for straight lines are functions. A straight line is really just a collection of points on your piece of paper that are in predictable locations. So you could have a collection of points that are just at random places, all over. Having to tell somebody where those points are would require actually writing out every single one of those points' locations. That's kind of a pain in the butt. With a straight line, all the points are in predictable positions. you see that there's this path that these points are taking. So then you can predict that, oh, another point that would probably be in this collection of points would be over here, because it would be on this same trajectory that you see going on. So that's what a straight line is. A straight line is just a collection of an infinite number of points, and it's represented by a function that when you give it an x value, it'll give you a y value back, saying where you have a point. So the most generic way to write I don't think I want to use that color. I want to use this color. Nah, that color. There we go. X plus, and then what's another easy to see color? There we go. B. So the equation for lines, the function for lines, looks like this. This is how you can ask, hey, do I have any points for this graph at a certain x value? And then your function's going to be like, heck yeah, you do. You have it over here. The m is just a number, but it's a number that actually represents something. That's your slope. Or how steep or shallow your line is. B is also just a number. It's the y-intercept. So your y-intercept would just be the point 0, comma, and then whatever that b number is. So if I gave you an equation, y equals negative 4x, what was the other color? Green. Plus 3, you know that your slope is negative 4, and you know that your y-intercept is at 0, comma. Also, I wanted that to be a negative 3, not a positive 3. See doodle. Minus 3. Now, it's really easy to picture what the y-intercept looks like. You just give yourself enough y tick marks, and then you plop a point down, and then boom, that's your y-intercept right there. That's where 0, negative 3 is. But slope, how do you visualize that? It means, like, how steep or shallow your line is, but, like, how do I know what numbers mean a really steep slope and what numbers mean a really shallow slope? And as a matter of fact, how do we know what numbers mean a line that's sloping up or a line that's sloping down? How do we know? Without showing you how to compute slope, a general understanding is that the bigger your slope number is, so let me get rid of some stuff. The bigger your slope number is, the steeper your line is. So if your slope number is like 2 for one line, and for another line, the slope is 50, one line is going to have a slope and the other one's going to be a lot steeper. So the bigger the slope number, the less likely you would want to have to climb that surface. Like if it was a mountainside, the smaller the number, the more you're like, oh yeah, that's not as steep, I would like to climb that, not this monster. So the bigger the slope number, the more steep the line is. Not for one line, no. It's like saying, without, like, scientific medical intervention, can you naturally have two fathers? Like, biological fathers. Like, chromosomal, they are the one that gave you your Y. Well, if you're a boy, like, if you were assigned male when you were born, so meaning you have a Y chromosome, can you have more than one father who gave you your Y chromosome? And the answer is no. It's the same kind of thing with slope. A line only has one slope. You know, a line cannot be this steep and this steep at the same time. So I guess a better way to say it is like being alive or dead. You can't be alive and dead at the same time, so a line can't have a slope of 2 and a slope of 50 at the same time. That doesn't really make any sense. When I gave the two subscripts, so m sub 1 and m sub 2, that was just saying that I had two lines. I had a line that had a slope of 2, and I had another line that had a slope of 50. Two different lines. So if they have different slopes, they're not the same line. They can't be. Here's an even better analogy. A slope is kind of like a birthday. Can you be born on multiple days? So, like, yeah, my birthday is May 1st, but also April 2nd. Not really. So a line can only have one slope. It can only have one steepness. And it's the same with y-intercept. A line can only have one y-intercept. Okay. Now, we have a general idea of what these things are. Now, there's a way to compute slope. The y-intercept, you almost don't have to compute. If you have a picture of a line, you just look at where your line hits the y-axis. You look at what the coordinates are for that y value, and you're like, oh, that's my y-intercepts, that's my b, and then you're done. It's that easy. For slope, it actually requires, like, doing some adding, subtracting, multiplying, dividing. You know, you can't just look at something and go, oh yeah, that's all it is. So slope has a technical definition. Slope is defined as the difference in y values between a couple points on a line, divided by the difference of the x values for those same points. So y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So what this is saying is that you have one point that you saw on your line, and it had a set of coordinates, and you saw that there was another point on the line, and it had a different set of coordinates. You're going to compute the difference of height between those 2 points and the difference of left-right position of those 2 points. And when you divide the difference in height by the difference in left-right position, that's your slope. So let me put a line on our graph here. I'm going to just say that that right here is the value -5. Let's say that. Alright. And let's say that this x value right here is 5. We know where our line is hitting the y-axis. What? Did I explode? Or did I sprout, like, a tail? What happened? I'm freaking out, man. I'm freaking out. What's going on? Did the universe break again? Is 1 + 1 equal to 11? What's going on? I'm panicking! Oh. I thought you... let me see what happened. Wait, so you can't put emotes in chat right now? That's weird. Let me look at that on Steam's end. Not Steam's. Twitch. Wait, what? Okay, I'm gonna put an emote, and let's see what happens. Huh. Can you not put an emote down? Oh. Oh. Also, I just realized the computer thinks my eyes are just absolutely closed. Oh. Okay. So it's not anything that I was explaining, it was like a technical... Okay, I got it. I understand. Crisis averted. We're fine. Okay. So, I have this red line, and I said that it hit the y-axis at a y-coordinate of -5, and I also said that it hit the x-axis at an x-coordinate of 5. We know what our y-intercept is right now. Because this point is 0, -5. Whoops. So, That right there. Never. That is our y-intercept. So for our line, we haven't really calculated what our slope is yet. But at least now we know what our y-intercept is. It's -5. Now, to calculate slope, we need to give ourselves 2 points that are on the line. We already know where 1 point is. It's the y-intercept. It's 0, -5. I didn't really say what any other points are on this red line, except for one. This guy right here. Since it's on the x-axis, and I told you where it hits the x-axis, you know what the x-coordinate is. And to be on the x-axis, you can't have a height above or below y = 0. You can't have gone from the origin and gone up or down at all. You could have only have gone left or right to stay on the x-axis. So you know your y-coordinate is a 0. Now we have 2 points. Now, which point you call point 1 and which point you call point 2 doesn't matter. It's helpful to say that points that are more to the right are your second point. Since you read things from left to right, so you would say that a point that is more to the left happened quote-unquote first. So we could, for the sake of calculating slope, say that this is point 1, and then we could say that this one is point 2. That means that this would be our y2 coordinate. This would be our x2 coordinate. Our y-intercept would also be our y1 coordinate. And then this would be our x1 coordinate. Why was your head anywhere near your keyboard? Ah, well, it happens. I've done it. Okay, so to calculate the slope for our red line, we take our y2 coordinate, which was this 0, minus what our y1 coordinate was, which was the -5. It's useful to use parentheses if you're plugging in a negative number for one of your coordinates, so that you remember, oh, I have a negative times a negative, so that's actually a positive, a plus sign. And then our x2 value is a 5. Minus, our x1 value is a 0, so we'll plug in a 0. I'll even draw little lines that are showing where these numbers came from. So, from there, and from there, and then this one came from that's an x value, right? I picked the x value. Alright, so that came from there. And this one came from here. Okay? So we get a 0 plus 5, because a minus and a minus is a positive. 5 minus 0 is 5. 0 plus 5 on the top is just 5. We have 5 divided by 5. A number divided by itself is equal to the number 1. So now we know what our slope is. Our slope is a 1. So then the equation for our line is y equals 1 times x minus 5. Now, we don't have to write that blue number 1, the one that's in front of the x, because if you have, say, 1 times 3, you don't say that it's 1 times 3, you simplify it and you say it's just the number 3. If you have 1 times, pi, you don't say it's 1 pi, you say it's just pi. When you have 1 times anything, you don't need to write that 1. And so, the actual equation for our line will look like this. Y equals x minus 5. That's the equation for our red line up there. Y equals x minus 5. Okay? So that's slope-intercept form. Let's give one more example where I actually draw the line and I tell you points that are on the line, and then ask you to make the equation. So, file, new, don't save. Okay. Put my coordinate axes back down. So, boom. There we go. Alright, what else do I have here? I can! If you really want me to, I can! Oh, good lord, I just looked at your DM. How did... Wait, why didn't it show up in just the general chat? What? Okay, I will. Let me actually finish talking about lines though. I want to make sure that you fully understand what I'm talking about. Okay. So, let me draw another line. So, let's say a line that's like this. But I don't make things as easy for you this time. So, I tell you what this point is. So, let's say -3 and y equals 7, and I tell you what this point is, -1, and that's about here, so then that point. So we'll say that's y equals 6. Okay, so I have this line, but then I give you 2 points that aren't necessarily really nice. We need to figure out what our y-intercept is, and we need to figure out what our slope is. We know that slope is equal to the change in y values divided by the change in x values if you can get yourself 2 points, so y2 minus y1 all over x2 minus x1. And we know that b is where you hit the y-axis. But unfortunately, I didn't tell you where we're hitting the y-axis. I have only given you 2 points. And I didn't even say what the points were. I just put tick marks that are lining up with the dots. So first off, we have to figure out what those points are, and then go from there. Well, this point right here, it looks like it's the one with a height of 7, and it looks like it has the x position of -3, so we can write what that point is. -3, 7. Alright, so we know what that point is. This next point looks like it's at an x position of -1, and a y position of 6. So now we have 2 points. Well, that's good, because to calculate slope, you need 2 points. Now, which one we call point 1 and which one we call point 2, again, doesn't really matter, but it's helpful to say that point 1 is the point that's the farthest to the left. So that would be the point -3, 7. So we'll just call this one point 1. Which means that this one would be point 2, since we already said somebody was point 1. That means that would be our x1 coordinate. That would be our y1 coordinate. And then this would be the x2 coordinate. And this would be the y2 coordinate. So we could calculate the slope for this red line. So the slope for our red line would be the y2, which is a 6, minus the y1, which was a 7, all over the x2 was a -1, minus, and then our x1 is a negative number, so it would help to put parentheses around it, just to help the algebra out a little bit. negative 3. The top, not so hard to do. 6 minus 7 is negative 1. Over negative 1 minus negative 3 turns into negative 1 plus 3. The top of our fraction, there's nothing really to do, so you just leave it as negative 1. Negative 1 plus 3 is 2. So now we have some fraction. And I'm just going to write it again, but you don't have to. This is just to make it look a little bit nicer. So negative 1 half. This fraction is fully reduced. And so that's our slope. Negative 1 over 2. So we can replace our m with what our slope is. Because that's a blessing. Although shaving can be a pain, yeah. But yeah, we know what our slope is now. Now, we are practically done. We have to find out what our y-intercept is, but that's almost as easy as falling asleep. Because we know that the coordinates for the y-intercept are 0, b. B is a y value. 0 is an x value. Remember how we were talking about functions? And how functions were a way of listing an infinite number of points on your piece of paper, on your graph? You give it an x value, the function is then like, hey, you actually have points at this x value, I'm going to tell you what the y values for those points are. We need to find out what y value b is. So let's give the function the x value 0 and see what y value it tells us. Oh. I just realized that's stupid. If we plug in x equals 0, negative 1 half, 0, plus b, negative 1 half times 0 is 0, plus b. 0 plus b is b. So the machine is like, okay, when you plug in 0, you get the y-intercept value that is the y-intercept value. It's kind of like saying, who gave me the banana? And then answering yes. All you did is you just acknowledged that somebody did give you a banana, but you didn't say who. So the person wanted to know who the banana giver was, and all you said is, yes, someone gave you a banana. So we can't just plug in x equals 0 into our function to figure out what specific number our y-intercept is. So then how do we figure out what the b value, the y-intercept, is? Well, if you look, part of the problem is that all we did is we just replaced the x value. Well, that left a letter still alive and still are in blah 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 in our function, in our equation, with another letter, b. If you want to solve for a specific letter, if you want to get a number value for a letter quantity, then it has to be the only letter in your equation. If you have more than one letter in your equation, you're not actually solving for any particular letter. You're not going to get a specific number value for a letter. You're not going to answer the question, who gave me a banana? So, we need to replace the x and the y value with specific numbers so we can actually figure out what the heck our y-intercept is. So we have to replace x and y with numbers to figure out what the heck b is. Now, we're dealing with a specific grouping of points on a graph. We're talking about a line. A line is a type of function where the points that make it up go in predictable places. You know that you're going to have another point here, and you know you'll have another point here, and another point here. To be on the red line, you're not going to have a point out here. Okay, that's not a valid point to be on the line, and this is not a point that'll be on the line. So, in figuring out what your b value, your y-intercept is, you can't just plug in any x value and any y value that you want. You have to plug in an x value and a y value that give you a point that's actually still on the red line. You can't just plug in any old x value and y value. You have to replace the x and y value with an x value and a y value that are actually on the line. You also have to make sure that your x value and your y value come from the same point. So, like, okay, I have a point here, and I actually know its coordinates. It's -1, 6. And I have a point here where I actually know its coordinates. It's -3, 7. I can't plug in a 7 for the y and a -1 for the x, because that would be a point over here. That's not on the line. So your coordinates have to come from the same point, because otherwise it's not going to be on the line, and thus you're not going to get your b value that's actually the y-intercept for that line. Okay? So, number one, you got to find a point that you know the coordinates for that is on the line. And then you have to make sure that when you replace x and y with their coordinates, they come from the same point. Don't accidentally mix and match point values. Well, we have 2 points that are perfectly good at giving us what the b value is. We could use -1, 6, or we could use -3, 7. It doesn't really matter. So let's use -3, 7. So we know that the y value is 7. If the y value is 7, then to be on the red line, we know that its x value has to be -3. So plugging those numbers in. Following the order of operations, we know that we have to do this multiplication first with the -1/2 and the -3. That gives us a -3/2. Not a -3/2, a +3/2, because a negative times a negative is a positive. So we get a +3/2 there, plus b. And then when you want to solve for a letter, you want that letter to be by itself on its side of an equal sign in an equation. This 3/2 is a neighbor to the b on the right-hand side of this equation, so we need to make it move to the left-hand side of this equation. So we're going to subtract by 3/2 on both sides of the equation. So we get 7 minus 3/2 equals b. And now b is solved for. We have a number for b. Now, the number is not in its most simplified form. But once we simplify it, then we're going to get a specific value for b. Now, to simplify this number, first off, we need to change 7 into a fraction, because we're going to be taking away a fraction from it. So 7, you can also write as 7 over 1. Another thing that we need to do is we need to give these two fractions the same denominator, aka a common denominator. What do they have in common? Well, they need to have the same denominator. That means we need to change the ratio 7 to 1 into another ratio that has a 2 on the bottom, but that it's still a ratio of 7 to 1. So how about 14 to 2? 14 to 2 is still the same ratio as 7 to 1, but now we've written it in a way where it has a denominator of 2. The way that you change 7 over 1 to look like 14 over 2 is you just make sure that you multiply the top and the bottom of your fraction 7 over 1 by the same number. That's how you can preserve what your original ratio was. Now they have a common denominator, so I got 14 over 2 minus 3 over 2 is b. And now I can actually do adding and subtracting with these two fractions. I got 14 minus 3, that's 11, over 2. That fraction is as reduced as it gets. So that is a valid result for our y-intercept. So now we know that our equation is y equals -1/2 x plus 11 over 2. Now, 11 over 2 is the same as 10 over 2 plus 1/2, which is the same as 5 plus 1/2, which, if you write it in decimal form, that'll be 5 plus a 0.5, so 5.5. Either this or this can help you actually graph, label where your y-intercept is. So we know that this location is at an elevation of 5.5, or 5.5, which is what 11 over 2 is. Now, you wouldn't write your y-intercept as 5 plus 1/2, because that's not simplified. And usually fractions are better to write than decimals. So you wouldn't write your y-intercept, your b, as a 5.5. You would leave it as 11 over 2. But yeah, that is how you calculate your equation for a line. That's slope-intercept form. That's pretty much everything there is to it. It relies on having either 2 points, or knowing where the y-intercept is, or knowing what the slope is and the point, or the slope and the y-intercept. But as long as you understand what the stuff means, as long as you understand that m is just change in y value over change in x value, which means y2 minus y1 over x2 minus x1, and you understand that that b is just 0, comma, and then where the line hits the y-axis, the height at which it hits the y-axis, then you'll be able to figure out, if you have enough information given in a question, to fully graph a line. So, like, if the problem is y equals 2x plus b, and you have a point 7, comma 12, you have enough information to figure out the total equation of a line and then to graph it. Because you can calculate the b by plugging in the 12 and plugging in the 7. And then you get your b, and then you can graph this whole thing. Or if you're given y equals mx minus 3, and you're given a point 8 and negative 4, you could figure out your slope plugging in your numbers. Or if you're not given a slope or a y-intercept, but you're given 2 pairs of points, so negative 1, 4, and 5, 7, you could calculate your slope, so 7 minus 4 over 5 minus a negative 1, and then use that slope number, plug that into here, and then use one of these points to replace the y and the x values, so you can find your y-intercept, your b, then you're off to the races. That's how you solve... That's how you do any kind of line problem. All of them. Okay? It just relies on you knowing that b, the number in the very back, is where you hit the y-axis, so you know that the x-coordinate that goes with it is a 0, and you know that m is just the difference in heights between 2 points divided by the difference in the left-right positions of 2 points. And that's it. So that's slope-intercept form. This is being recorded, and I should have this VOD completely up by at least tomorrow. So, if it doesn't make, like, 100% sense right now, just watch the VOD again. And for the few examples that I've given you, create your own examples and see if you can figure out your equations for a line and how you graph it. And then Google, like, sample line, sample slope intercept problems. Like, literally type this into a Google search. Sample slope intercept problems. And you will probably find example problems that haven't been completely done, so you could actually practice figuring out what information you have, what information you're missing, and how to fill in the blanks. But yeah, that's slope-intercept form in a nutshell. Okay. Now, if you don't have any objections, Mr. Brandon, I'm going to start blabbing about Euler's formula, because I think I can do it quick enough to actually show it all. But yeah, I'll stop dilly-dallying and get right into it. Also, if I'm seeing things correctly, actually, I don't know what... Okay, so, like, streamers that are really big, it's impossible for them to just open up the users and chat button and look at who all's in their chat and then say hi to them. So they usually don't do that. But, like, when you're small, and you have, like, a handful of people in your chat, is it weird to call out who's watching? And being like, hey, yo, what's up? Because that's kind of like outing a lurker and being like, oh, yay, dude, lurker, how's it going? When you're lurking, you don't necessarily want to be noticed. Okay. I'm going to err on the side of don't out people that are lurking, so I'm just going to say, hi, people in chat, that I think you're there. Hope you're having a good time. And also for any new names, yes, I am a free math tutor, and totally not a kobold using a human avatar so I can blend in with society. Yes. So, if you have any actual math questions, you can do like what Brandon did here and ask to talk about slope-intercept form or whatever, and then I will help you for free. Okay, getting that out of the way. Euler's formula, like the big banana. Okay. New, don't save. Cool. So the reason why I realized that talking about Euler's formula would be really cool is because we had talked about cubic equations and solving cubic equations. So like x cubed, I think it was like 81x squared plus... No, it was minus 15x squared. 15x squared plus 181x minus $1.25, I think. I have my reference book right here that was talking about cubics and all that stuff. Minus 15x squared plus 81... Oh, minus 175. Okay. So minus 175. We had derived a formula to solve any cubic equation. You first said, hey, what if x was some combo of variables? You find out that, oh, this combo of variables is u minus a over 3, where your cubic is written as x cubed plus ax squared plus bx plus c. You get your equation looking like this. U cubed, let's see, it was plus b minus, I think, a squared over 3 u minus ab over 3 plus 2a cubed over 27 plus c. If you make this substitution, where you just say that p is this number, And you say q is this number, ab over 3, plus 2a cubed over 27, plus c, you get this equation, so 0 is u cubed plus pu plus q. And actually, I don't think that was the sub that you do here. Yeah. You end up getting a solution for u, which is u... Because, like, right here, you make a substitution where u is, I don't know, nu minus blah. That's not nu. Mu minus nu, and then you end up getting a solution for u, which is the cubic root of negative q over 2 plus the square root of q squared over 4 plus p cubed over 27, blah, 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 plus the cubic root, negative q over 2 minus square root q squared over 4 plus p cubed over 27, blah, blah, blah. So, starting with this equation, and you do all this junk, you find that your x is just the u plus the v value. So I guess really was just a over 3. When you do that, you find that your x value happens to be a 7, your u value was a 2, but the equation that got you a 2 was this god-awful grouping of numbers. Let's see if I have it written down. It should have a square root of negative 121 in there. Yeah. Oh, I wrote down the wrong... Poopy. I wrote down what the wrong base equation starting was. All the stuff where it was just letters without numbers was fine. But the base equation that you start with was just x cubed plus 15x I think it was x cubed minus 15x minus 4. Yeah, because you get an x value equaling 4. But when you use your ugly equation right here, you find that the solution is 2 plus 11 times the square root of -1 plus the cubic root of 2 minus 11 times the square root of -1. And that is another way of writing the number 4. So, this was a solution that baffled mathematicians back in the 1500s because it made them realize that there are numbers that, if you square them, give you negative numbers back, which they hadn't really had any experience with. Those are the imaginary numbers, and that's a terrible name because imaginary numbers are not like unicorns. Imaginary numbers actually exist, but blah blah blah. Mathematicians started figuring out some stuff about calculus, namely derivatives. So we talked about those. So derivatives of functions, if you want to solve for the slope of a function at a certain point, was this f of x minus f of a over x minus a. And we derived what the derivative rule in general for polynomials was. It was this. And we also derived what the derivative rule for trig functions was, specifically sine. And we showed that it was this. And an identity that we used was this to help us prove that. And we actually proved that identity. Using that identity again, we can also then figure out what the derivative of cosine x is. It's a negative sine x. And a long time ago, in a galaxy far, far away, we talked about Taylor series, which is if you have a really gross function, it's possible to construct a copycat function that's actually just a polynomial that matches your original function in every way, meaning that whatever derivative of a function you have, it will match the polynomial's derivative. Ugh. So all of this would hold. So we were able to derive how to construct copycat functions. X minus c to the n all over n factorial. Okay. Once all this information was figured out, a huge breakthrough in understanding quote-unquote imaginary numbers came into being. So let's look at the number, say, 2 plus I, and its twin, 2 minus I. If we multiply these two numbers together, since this is a difference of two squares, where you got a number here that's the same as the number here, and a number here that's the same as the number there, you just get 2 squared minus I squared, so 4 minus -1, so you get 5. Okay. You can write numbers that actually exist. They have a quote-unquote real part and a quote-unquote imaginary part. If you give yourself a coordinate axis, so Control paste, but instead of having an x and a y axis, you have a real and an imaginary axis. We could plot this number, 2 plus I. The 2 would go on the real part. The 1, the ghost one that's sitting in front of this I, would go on the imaginary part. We have graphed the point 2 plus I. Once we've graphed this bad boy, we actually can do trigonometry with a number that has an imaginary number in it. We have an angle above the real axis. We'll call it theta. The opposite side of this triangle is the 1, or the 1i. The adjacent part of the triangle is a 2. And then if we use the Pythagorean theorem, we find that the radius, the hypotenuse of this triangle, is the square root of 5. So do the a squared plus b squared equals c squared thingy. Plug in 2, plug in 1. So you get 4 plus 1 equals c squared. C is equal to square root of 5. We can actually do trigonometry here, so the sine of theta would be a 1 over the square root of 5. The cosine would be a 2 over root 5. Our original number, 2 plus I, looks almost like the cosine of the angle above the quote-unquote real axis, added with I times the sine of theta, multiplied by the hypotenuse of our little graph, our little triangle, which we'll call R. So the square root of 5, the cosine of our angle was 2 over root 5 plus I, and then the sine of our angle was 1 over root 5. So distributing a root 5, all the root 5s are dead, so we just get 2 plus I. we find that we can write imaginary numbers, so a plus bi, like a sum of trig functions, cosine theta, plus I sine theta, where the tangent of theta is b over a, and the radius is the square root of a squared plus b squared. Well, a genius mathematician by the name of Euler came around, and he combined everything that I had just talked about. He looked at an equation, e to the x. It's an exponential equation. Also, I forgot to mention that the derivative for e to the x is e to the x, and that's a really easy proof to do. He did its Taylor series expansion, so he was like, okay, f of x would just be e to the x. If you do its first derivative, it's just e to the x, and if you do its second derivative, it's just e to the x. And it just stays that way forever and ever. So whatever derivative it is, if you plug in your number that you want your imitation function to look really good around, you just get e to the number. And so if you want the place that your imitation function looks really good at x equals 0, then you find that that slope is 1. And so you find that the Taylor series for this guy is 1 plus x plus x squared over 2 factorial plus x cubed over 3 factorial plus dot dot dot, going on forever and ever, and so written in sum notation, n equals 0 to infinity. You get x to the n over n factorial. If you want to find the Taylor series of sine of x, so if your function is sine of x, your first derivative is cosine of x. Your second derivative would be the derivative of cosine, which is negative sine. Take a derivative again, you get negative cosine. Take a derivative one more time, so the fourth derivative, and you get a positive sign right back. You see that you get this repeating pattern where, let's say if this was the number 4, then this would be the number 5, 6, 7, and 8. Yeah, so 0 plus 4n. Yeah. So every 4n term it will be just, of the derivative, will just be sine of x. If you plug in a 0 for your x, your center point, for this one you'll get 0, for this one you'll get 1, for this one you get 0, for this one you get negative 1, and then for this one you get 0 again. Plugging this into the Taylor series expansion, you find out that you get sine of x is 0 plus x plus 0 minus x cubed over 3 factorial plus 0 plus x to the 5th over 5 factorial plus And that pattern goes on forever and ever. And so if you simplify it, you get x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial plus blah blah blah. If you write that in some notation, so n is 0 to infinity, you get negative 1 to the n, x to the 2n plus 1, all over 2n plus 1 factorial. And then if you do this for cosine, so if you say that your function is cosine of x, you find that it's also a nice little repeating pattern. F prime of x is negative sine of x. F double prime of x is negative cosine x. F triple prime of x is positive sine of x. And then to the 4th derivative is back to where you started. If you plug in x equals 0 into all of these things, you get a 1, a 0, a negative 1, a 0, and a 1. So then the Taylor series for cosine would be 1 plus 0 minus x squared over 2 factorial plus 0 plus x to the 4th over 4 factorial plus 0 minus x to the 6th over 6 factorial plus 0 plus blah blah blah. You simplify that, so you get 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial plus blah blah blah. You write that in some notation. You get n is 0 to infinity, negative 1 to the n, but then x to the 2n times 2n factorial. The genius thing that Euler did was that he took the Taylor expansion of e to the x (0 to infinity), which is x to the n over n factorial, and he said, hey, what if I plug in the imaginary number and then times some other variable or some constant or whatever? What do I get? And, well, this is what he got. He got I blah 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 0 over 0 factorial plus I theta to 1 factorial plus I theta squared 2 factorial plus I theta cubed 3 factorial plus I theta to the 4th 4 factorial plus I theta to the 5th 5 factorial plus la la la. Simplifying, you get 1 plus I theta over 1 factorial minus theta squared over 2 factorial minus I theta cubed over 3 factorial plus theta to the 4th over 4 factorial plus I theta to the 5th 5 factorial, and then minus, and then that pattern just keeps going and going. If you group all of the terms that do not have the letter I, so are not imaginary, and you just have them listed first, you get 1 minus theta squared over 2 factorial plus theta to the 4th over 4 factorial minus theta to the 6th over 6 factorial plus blah blah blah. And then you add all the terms that have I. So you have I theta over 1 factorial minus I theta cubed over 3 factorial plus I theta to the 5th over 5 factorial minus la la la. We factor out an I from all of these guys forever and ever and ever. So just recopying the first pattern, theta to the 4th over 4 factorial minus theta to the 6th over 6 factorial plus blah 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 plus I times theta over 1 factorial minus theta cubed over 3 factorial plus theta to the 5th over 5 factorial minus da da da. That's the Taylor series expansion for sine of theta. And this stuff right here is the Taylor series expansion for cosine of theta. So you get cosine theta plus I sine theta. And then remember, we all started with just e to the I theta. So I can replace the variable theta with whatever variable I want, so it's just sometimes a little bit nicer to look at it by writing it like this. Sine x. No. Cosine x plus I sine x. Well, if you remember, mathematicians had figured out that you could take numbers that have imaginary numbers in them and then write it as if they were a trig function. So the square root of a squared plus b squared times cosine of the angle theta plus I sine theta, where the tangent of theta was b over a. Well, right here, Euler was able to demonstrate that, and actually I should have just put an R here, and then define what R was, blah, 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 blah. And then R was the square root of a squared plus b squared. Euler was able to show that a plus bi, which equaled this, plus I sine theta, also equaled this, or e to the I theta. This is stupidly important because if you want to find, say, what the cubic root of a number like 2 plus I is, that looks stupidly hard. How the heck would you do that? Well, rewrite 2 plus I as its radius, so 2 squared plus 1 squared, times the cosine of the angle, so the inverse tangent of 1/2, plus I sine the inverse tangent of 1/2, and also I really could have just written this as a parentheses right here, and it would have made things a lot easier to look at. Well, that's the same as the square root of 5. Oh, and by the way, 1/2, so 1, 2, and there's the angle. So square root of 5. I realize I probably should have used a nicer number that I could actually compute by hand, where I know what the angle is. It would be easier to write. 60. So... okay. So if you want to find, like, the cubic root of this number instead, 1 plus the square root 3i, then plugging in your numbers, blah, blah, blah. So, square root 3 over 1, and square root 3 over 1, this one, gotta fix, this is 1 and root 3 squared. That simplifies down to 2. And then e to the I times pi over 3, because this is actually a nice reference triangle that I have now used. Because really, you should... if you're doing a demonstration and you're trying to figure out numbers by hand, you should use reference triangles like 30, 60, 90s, 45, 45, 90s, all that stuff. So 60 degrees, 30 degrees, 1, 2, square root 3. And 60 degrees is the same as pi over 3 radians. So there we go. So then the cubic root of 1 plus square root 3i would be the same as the cubic root of 2e to the I pi over 3. Cubic roots are the same as exponents that are a 1/3. So we have the cubic root of 2 times e to the I pi over 3 times 1/3, which is the cubic root of 2 e to the I pi And so then you find that your answer is negative cubic root of 2. So the cubic root of a weird, complex number ended up being negative cubic root of 2. That came from Euler's formula, so r e to the I theta is r cosine theta plus I sine theta, which is a plus bi. The radius is the thing here, and theta is the inverse tangent of b over a. And Euler discovered this connection by using the Taylor series expansion of e to the x, sine of x, and cosine of x. So he found a link between trigonometry, e, which is a number that actually comes from compound interest, and I might talk about that at some point, and approaches infinity of 1 plus 1 over n raised to the n. So if you have a bank account that has 100% interest, but it compounds approaching an infinite number of times, you get a number that's about 2.72. So you combine the natural number, which is related to compound interest and also a bunch of other things in nature, with trigonometry, which is the mathematics of circles and also cycles. Anything that is cyclical can be described with trigonometry. And connected all of that with complex numbers, so numbers that if you square them could possibly give you a negative number back. He was able to connect them all with his formula. And the most beautiful thing from his formula was when he said, okay, I'm going to have an r of 1 and a theta of pi. So e to the I pi. So plugging it into his formula, he got cosine of pi plus I sine of pi. So we got cosine of pi plus I sine pi. The sine of pi is 0 because pi is an angle that's over here. A triangle that you would write with it would have an internal angle of 0, so the opposite leg would be nothing, so sine would be nothing. Cosine would give you a -1, since it's the hypotenuse and the adjacent leg laying right on top of each other, but pointing in the negative direction, so you get -1. So e to the I pi equals -1. So he went even a step further by combining the natural number e with one of the most famous irrational numbers ever, pi, which is in trigonometry, but also in anything that is cyclical, and also pops up a lot in probability as well. And he also connected it to the concept of negative numbers. And another link that he has with it is the class of numbers that where their square roots are -1. Oh, and also he linked it with 1, which is like just the most basic universal number. This is like a special case of Euler's formula. It's considered one of the most beautiful equations in mathematics. Because of all of the different branches of math that existed up to the point of the 1700s, which is when Euler lived, because I think he was like late 1700s and he lived into the very early 1800s. It combined pretty much all the areas of math that existed at that point into an equation that had e, I, pi, an equal sign, a negative, and a 1, that only had 6 symbols. So that's Euler's formula. It's one of the most nutty things in mathematics. And that was the thing I wanted to blab about for a little bit. So I did. I might go through a more structured derivation of it, where I'll just sit and go through what basic stuff I have to explain, instead of just saying, oh, just trust me on this. But yeah, that's Euler's formula. It's a very nuts thing that is deceptively simple looking, but is very foundational and fundamental. Oh, and also, if you just add 1 to both sides of that equation, you get e to the I pi plus 1 equals 0. So in here, it's linking also the concept of nothing as something. That the concept of nothing is a number, just like 1, 2, or pi, or whatever. So it's a very nutty equation, and it all came from Euler's actual formula, which is this. So cos theta plus I sine theta, which is a plus bi, where the r is the square root of a squared plus b squared, and the theta is the inverse tangent of the b over the a. So yeah, Euler's formula. It's ridiculous. And when I was first able to kind of follow explanations and able to rederive it for myself, it's almost like standing someplace where like a famous historical person once stood. And it's kind of humbling just to kind of realize, oh, that's where this came from. And it makes logical sense. It's not like something that I have to just accept. It's a concept that was true before Euler was able to write it down and prove that this was a real concept. You know, this concept had existed since the universe, at least our observable universe started. So it's an insane part of mathematics that is eternal. And kind of beautiful. It's something that we humans have only figured out in such a short amount of time, in like a small time period of our total existence. Because Euler lived at most 300 years ago. Humanity has been around possibly for 300,000 years. So, we've only known about this intricate piece of mathematics for 1/10,000th of the total existence of humanity. No, 1,000th. There we go. It's just rare that we humans get to touch something of the eternal. Something that is just there. And when we get to see it and we get to comprehend it, it's... You know, like looking at the night sky when you're out in the forest and there isn't any light pollution. It's pretty magical. But yeah. So, I'm done blabbering about math. If nobody has any math questions, I'll go ahead and boot up Silent Hill, so we can start playing the New Game Plus. We had gotten to the doghouse, which is funny because we're not actually in the doghouse. We're in the house that has a doghouse, but the save file still calls it doghouse. Think about that, Mr. Batman. Okay, I'm gonna shut up. I'm just rambling. Don't save. Okay, so give me a sec. I'm gonna boot stuff up. There was another guy who had come in on Thursday who told me about a lot of emulating software. So if I play any more PlayStation 1 games, I'll definitely use not RetroArch, but something else. But for right now, since I already have save files with RetroArch, we're just going to keep with that program. So forgive me if things look kind of gross. Forgive me, for I know not what I do. Okay, so... say goodbye to the Metroid Prime soundtrack. And say hello to just silence. Nothing. Yeah. Okay, now, just checking. Brandon, are you still there? Are you awake? Are you alive? Can you hear me? Speak to me. I beseech thee from the grave. Knock 3 times if you are present. We're having a seance, by the way. I need to edit the stream info. Okay, because now we're actually going to play a game. Until somebody has a math question, and then we'll actually, like, answer their math question. And then jump back into Silent Hill. Oh no, I think I closed my Discord. So I can't just talk to my mod. My desktop is a mess, I just realized. I used to have it like so nice and organized, and then over the past year and a half, it's just become a sea of disorder. Right. NP. So, are ya still alive, Brandon? Are ya winning, son? Is he there? Answer me, boy. Oh well. If he's not there, I'm recording, so that's good. So he'll be able to watch the VOD. Uh, and I also realized I don't have my controller, which was stupid. I am such a professional at this, guys. You have no idea at all. Cool. Well, you're right in time because I'm gonna start. Ugh. Okay. I didn't need that open. Why did I do that? Also, Discord doesn't need to be up there. This doesn't need to be as far up as it is. Okay. Unfortunately, we're gonna skip the intro song because whenever I upload the videos to YouTube, yeah, no problem. Uh, uh, I don't expect any of the videos that I upload onto YouTube to be monetized at all. Like, I'm not worried about that. But, I don't necessarily want ads to just appear on a YouTube video that I upload uh, that are going to go to some shady company that had no hand in creating a piece of content and yet is now filing copyright claims simply because they got the rights to a certain property. So yeah, we're not going to give them the satisfaction of being able to run ads on my videos by not playing music. Shut up. Alright, so here we go. Ow. Ow, 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 ow. That was loud. Okay. There we go. Oops. There we go. Oops again. Sorry. Sorry. There are violent, disturbing images in this game. Good. Come on. Come on. Oh! Whoops. I hit start a little too quickly. Alright, so is everyone ready? Everyone ready to wish they were dead? Because this is on hard mode. Um, uh, Dang it, I keep pushing the wrong buttons. It's on hard mode, and I suck. Okay. I think I have everything on the map. And also, I think I have a pretty decent amount of bullets. Yeah, that's okay. getting dark again? It sure is! What's going on? I don't know, Harry. I don't know. Okay. Health to drinky. Also, let's check the options and make sure that things are set right. Okay, good, they are. Good, good, good. I'm totally not cheating by using a bullet multiplier so that I get more bullets per item drop. Because that's what cowards do, and I'm not a coward. Now, I don't know how far I should go exploring, because I don't really know what all is worthwhile to go look for. So give me a minute, let me consult my memory. Okay. New street, steel pipe, handgun bullets, key of lion, scarecrow. Key of woodman. Trash bin just beside the key of woodman. Handgun bullets off of Methodist Street between Bachman and Ellery Street. I think I got all those. First aid kit, yes. Health drink, yes. Note of doghouse. House key, I got that. Okay. We're not going to have a katana until the second New Game Plus. Let's see. Handgun, bullets on the dying, blah blah blah. Drink. Who turned out the lights? Alright. So, on a table in the backyard of the house, on a table in the backyard of the house. By the eastern bridge supports of the broken bridge at the northernmost point of Midwich Street. So there's going to be some handgun bullets on the eastern side of the alleyway, stretching between Matheson and Block Streets. Alright, where's Matheson and, Block? So, Matheson and Block. Okay. On the easternmost side of Matheson and Block. So on Midwich. Right? That's what it said? On the eastern side of the alleyway, stretching between Matheson and Block Streets, supplies and nutrition, blah blah. By some trash bins on the western side of the alleyway, stretching between Matheson and Block Streets. Okay. So, I don't know why I hit my controller while looking away from the game. Okay. So... Okay, come here, you little... Ah. Heh. I win, you lose, you die, I live. That's the warrior's way. Conan, what is best in life? Anyone out there seen Conan the Barbarian, the Arnold Schwarzenegger movie? Which is, like, older than me. And that makes me surprised. Ooh! Come back here. Okay. I am pretty sure that there's not really any items on Finney Street. Oh yeah, because Finney Street's blocked off. Yeah. Okay. These are just houses. That's a dog. Where's the dog? There's the dog. Oh, I, like, killed it. Okay. So for any of you that are planning on playing this game, with dogs, wait to shoot them until their head is facing you. Which can be kind of nerve-wracking, because, you know, they're charging you. And shoot them sooner than what I just did. Okay. But if you wait until they, like, show their face at you, you'll do a lot more damage and thus save a lot more ammo. Is there anything in here? Besides actually kind of a cool, collapsed, bridge. Running along. Yes! What the? What do I hear? Okay. Health drink. Handgun bullets. I had, I think, 50 set. That's not the item button. Reload. 85, alright. It's good stuff. Alright, it said there was an alleyway between Matheson and Block. Oh! Yeah, right there. I understand. I think what I'm hearing is a dog. And it didn't notice me, so I'm just gonna keep going. Haha! Okay, camera, stop it. I would like to see in front of me, not, you know, behind me. Who could it be, this animal that I'm wondering about? Oh! It's a dactyl! Hey! Oh, look at him, he's walking! Hey, I'm walking here! But he's also kind of stuck. I don't know why. Hey. I don't know why I missed the first 2 times. Okay, that was 4 wasted bullets that I'm never gonna get back. Wait, no, he's still here. Where did... Oh, okay. So... Wait. Oh, that's not the same one. Cool, I hit it. Oh, I still have, like, almost 80 bullets. I like that. Okay. Something that I didn't realize is that when you beat the game, and then you go into the New Game Plus, your brain dies. No, your brain doesn't die. But it ups the difficulty of the game. So it's really nice that they also gave a bullet multiplier function. Because the monsters have more health, and also I get more panicky and my aim is worse. Oh. Right, it's pterodactyl. I think I heard little flappy flappies. Don't ask me why I'm seeking it out instead of just, oh, hi! What? You ever step on a cockroach, think you've killed it, lift your foot, and then it just runs away? Yeah, I think that's what that monster just did. Except that it ate my bullets. Jerk. Woo! Alright. Where was I? Is that a dog? I hear footsteps. Oh, there he is. Okay, I see a little silhouetto of a dog. Oh crap, of two dogs. Okay, good. I got your attention. Okay, hurry, kick him. And then... and kick him. Sometimes I feel kind of bad, because it's like... what if those were just normal dogs? And I'm just having, like, a really bad drug trip. Thinking that they were, like, skinless monsters. Hey! Wow, that car is almost falling over. Looks kind of cool. Okay. You ever play a game and think, wow, I would really like to visit this place? Would it be weird to say that I kind of feel the same with this game? Because Silent Hill looks like, if it wasn't, like, cut off from normal mortal existence and wasn't flooded with monsters, it'd be kind of a pretty place to visit, Nice and cozy. Not exactly all that dirty of a... whoop. Oh, you're behind me. I don't know why I shot it again. Because, like, it just flew away. And I don't think that's a birdie that I hear. I think that's a dog. Okay. Matter of fact, I think I hear two dogs. Yeah, I heard a... Oh! Okay, where's the other one? Oh no, and a birdie. Where's the birdie? Okay, die. Turn around. Urgh. Okay. Where'd the dog? Come here. Why? Oh. Oh, that was so close. Oh. Oh, my hands are sweaty. Mom's spaghetti. But I'm not wearing a sweater, so there can't be vomit on it. Oh. Bird flying. Nope. He hears me. Why did I shoot there? No, come here! I'm sorry, I had to put you down. Also, this would be like an introvert's, like, ideal tourist location. Because there's no one here! So you just be by yourself, able to explore at your leisure without, like, worrying if someone is looking at you. A paradise, if you will. Why am I crossing the street? Alright, what monster is it? I think it's a dog. Oh, yes, it is a dog. Hello! I unfortunately shot a little prematurely. So that was the alleyway that I came from. Oh no, no, no. I love it when I point in... There we go. Death. Oh. Alright, I know it's a... Oh, I see him! He's right there. Like, center of the screen. Come here! I have, bacon strips. Crap. Crap. Bird. Whoo! He almost hit me. Okay. Alright, where are you? No. If I put bullets into you, you let me kill you. Okay? That's the deal. That's our contract. Alright. Let me consult my memory again, just to see if I'm missing anything. Northernmost trash bins on the alleyway, searching between Matheson and Block, sitting on the front, right side seat of a school bus. Oh, okay, so the only extra thing that I gotta do is hop over to the school bus. the magic school bus, if you will. Where are you? Oh, there you are. Okay. Hello. Come here. Hey, puppy. Come here. Hey, moo. Why am I not drawing aggro? I don't get it. Hello. Okay, I'm not sure if he bit me or not. No, he didn't. Alright. Oh! And here's the waterworks. We have to go through this way much later in the game. It's locked. I wonder if I can beat the lock. Like, if it's even targetable. Because we have to break it. Apparently not. But I like that little bit of foreshadowing, saying like, hey, this is going to be useful at some point. Oh no, excuse me. Pardon. Alright. Pretty sure there's going to be a couple dogs coming up. I don't think any birds, though. Oh. Now, why is it so quiet? We're at the front of the school, I know that. And the school bus is beyond, I guess, behind that sign. But I'm pretty sure there's supposed to be a couple dogs. Alright. I hear one. I don't see it because there are trees, and the camera angle really does not want to work with me. Where are you, big guy? Come here! Okay, I see him. Now, does he see me? Yes, he does! Okay, and there should be another one. Oh. Okay. He's behind the school bus, I'm guessing. Come here! I will only kill you! Crap. I gotta get into good... Oh! Great. Perfect. Lucky number 13. Cool. Hey, let's hop into a school bus and go for a ride. Just call me Miss Dazzle, and not Miss Frizzle. Have a drink. I will take that, and I will take that. I wonder if there's actually any story foreshadowing stuff on the bus. I've never really looked. Okay. Anything? No. Save point, yeah. But are there any, like, handgun bullets on this bus? Well, I guess that's a no. I'm fantastic. I don't know why you called me a knob, though. Oop-a-doop. Hold on, I gotta consult my memory. Huh. Oh, that's what you meant, huh? Okay. I'm kind of proud of myself with this playthrough. Um, I have like 14 health drinks, which is a lot. 3 first aid kits, and I still have like 15 plus 51, so 66 bullets in my handgun. So, like, things are actually going kind of well, and this is on hard difficulty. So I'm getting a better hang of... Come here. Oh, bird. No, bird. Bird. Okay, bird left. Now, how many dogs? I see one. And I hear a bird. I hear a bird. I hear a bird. I hear a bird. I'm booking it. Come here. No. And it's a different bird. Nothing. You actually didn't really miss anything. I just walked around, picked up some items. Now I have 10 less bullets than I should. That really sucks. But yeah, I was just heading to the elementary school. Alright, come here, dog. Why did I miss? Why did... Okay. Why? What? Oh, this is going so bad. This suddenly went really bad. No, actually. Command. We're gonna reset the PS1. Like, after I saved, things just went to hell. But yeah, no, like, it's been pretty, quiet. Well, you know what to do. What? Wait, what? No. Oh, yeah, no. If it's somebody watching this, like, a channel as small as ours, and they have, like, thousands of followers, it's a bot. It is absolutely a bot. Especially if they haven't said anything in chat. Yeah. I thought you were saying that, like, we suddenly had, 10,000 followers, and I was like, ha! Man, how do you fix that? Crap. Don't play that music. I don't want YouTube to have to be like, hey, we're gonna throw a bunch of ads on your video, for, you know, unethical companies that are abusing copyright law. Haha. Alright. So, there are a couple birds. I don't care. I'm gonna sit here. Okay. Ah! Why? Audio options, reset, menu toggle, pause toggle. Yeah, okay. Let's... Why? What happened? Like, I'm suddenly... I had a rhythm and everything. I was playing well. And now it's just back to... You know, I'm gonna throw my gun at people instead of shoot them. Okay, now that's just being sadistic. Although if it's a bot, it doesn't have emotions, so you can't make it suffer. Alright. Okay, we're gonna save state. So that I don't have to do the whole really long reload.
Oh, hi, thanks for checking in. I'm still a piece of garbage.
Eat booba.
Did you say eat? Really? Why? That's a waste of perfectly good, assets. Like, if you eat them, then they're not going to exist anymore. You know? It's like, when you appreciate a nice piece of art, you don't...
Thanks for checking in. I'm still a piece of garbage.
Suck booba milk.
I mean, I won't yuck people's yum. But that is kind of weird. Alright, where are you? Okay. Where is it? Yes, but that's because babies are meant to do it. I wasn't even holding X. Where'd he go? Ah well, if he just flew away and he is not coming back, which unfortunately it sounds like he's coming back. Alright. Oh! Load. Oh, I didn't do it. I forgot. What's up, EA? Oh, Brandon! You haven't met this guy yet. EA came in on Thursday while you were out. EA, meet Brandon. He's me mod. But yeah, I'm back as promised. I'm just trying to get through this one segment without, like, getting hit by a million monsters. And it doesn't seem like it's working, so I might as well just rush the door. Yep. Rush the door. Okay. And that turned out to be the best solution, was just to rush the door. I don't know why I did it. Well, I wanted to fight my way through, but it's like it triggers a pterodactyl that comes at you from behind. If you walk closer to the door, then it triggers a second pterodactyl that comes at you from the front, and then the closer you get to the door, then you have to fight 2 dogs. So it's like I couldn't really find a good way to get through and also kill everything. Yeah, and it doesn't make any sense, because it's, you know, an image file. There's no CD to read. Drag him out of bed. He stayed up all night playing Fortnite. Don't believe what he's... Brandon's just upset because I'm going to be a pro Fortnite gamer and he's not. Ooh. Oh yeah, this is Nurse's station. This is where save point is. I'll take that. And I'll take that. I don't think there's anything else in here. Wait, is there such a thing? Also, I feel really stupid asking that. Okay, so we're in the school. Oh. Oh, I think these are all just, like, notes and stuff that I already have. Yep. I've written down all this info a long time ago. Darkness that brings the choking heat, flames under, blah blah blah. That's a sad thing. Oh, what is this? More Ronaldo Gordon. This must be a list of teachers. Yeah, that still really sucks. I am still really sorry that that happened. Okay, so it's just a painting at this point. I don't know who drew it, but it is certainly in bad taste. Ooh, thank you. I like bullets. No, don't use. Hold on, I thought that was bullets and reloading. Oopsies. How many buttholes does the devil have? Wait, what? Bullets are devil's buttholes? In junior high, there were plenty of devil's buttholes. Okay, locked. I think this other door is also locked. Opening the door. There you are. Hello. Wait. Wow, they need a lot of bullets. What about if I just hit them over the head? Does this require as many? Hey! I hit you! I feel like they have twice the hit points that they normally do. Ha 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 ha! Whoa. Oh, wow. When we had Player on Music Day in music class back in the day, the teacher would not play my song Pepper because the band name was the Butthole Surfers. What the? What grade was this in? You had a very developed taste in music for a 6th grader. Okay, so I see all that information. I don't think there's anything else in here. Alright. Also, I don't think monsters appear in this courtyard ever again. Oh, you son of a... Oh! That's not fun. Oh, okay. That makes a lot of sense. Wow, they... Ooh, okay. Oh, no. Wait, so then what genre were the Butthole Surfers? Read about seeing the Beach Boys in '96 when kids my age said they were... Oh. Well, those kids weren't very smart. I guess I did not kick this guy to death. Seriously. Like, not even all the members of the Beach Boys are even alive anymore, are they? So it's like, it's impossible for them to have a full reunion concert, because some of their members are dead. Alright. Hey, it's with the sad ghost of Alessa, I think. Oh, okay, so they died really young. Alright. I'm so sorry, little baby ghost. Okay, so try that door. That door won't work. Was that... I get it, I don't have the map. Which makes me think... I bet you I accidentally skipped the map. Yeah, I probably accidentally skipped the map. So maybe at, like, the administrator's office. Bare Naked Ladies wrote a song about the one guy, Brant. Really? Okay, Huh. Which map? Oh, yep, there's the map right there. And it was right next to a map of the US. I don't know how I walked right past that. I am... Like, right now, you guys, you're watching the epitome of gaming skill Oh. Punch me in the face. Okay. Doo-dee-doo. Alright, the double doors that I think work are the ones on the left. Which means these double doors should not work. Yep, cool. Yep. But these double doors should work. Yep. Alright, little guy. Come here. I've seen PewDiePie play games. I know how much of... Man, that is rough. Although watching him play Among Us was really funny. Oop. Why did I miss? I was going nice and slow and steady. Alright, and you, please stay down. I will say this. The, Let's Player's curse is real. Like, having to talk and play games makes you dumber. By a long shot. Alright, so nothing in the bathroom. Let me just double check. I know! Like, that's something that I've kind of come to grips with, is that if I want to really be entertaining, I need to be okay with being dumb. Oh. You know, it's like, it's the Schadenfreude. Oh. Good night. What, because we're both very old? Okay, we're not very old. I'm good at pretending that I'm good at math. Oh dear. Well, I graduated high school... Here's a better way to keep things anonymous. My last year of high school, had 9/11 in it. Oh good lord, you're younger. Oh no. Yeah, I'm a dinosaur. Although I graduated in '02, so that's not that, like, that's just a year earlier. So, would have gone to high school. Yeah, essentially, I would have been a junior when you were a sophomore. That's awesome. Boomer solidarity. So, Brandon, you have two people in chat that are old enough to be your parents. Yes. Yeah, same with me. Wait, yeah, I'm turning that number. I can't say it out loud. That's... Oh, lordy. Alright, where are you, kid? Come here. Five. Dead. Don't! I don't want you to say your age. And you're not stupid. Being young and being stupid are two completely different things. Now, being young and being inexperienced, okay, those go hand in hand, but no one can actually hold that against you, because, like, you know, you have to have experience to have experience. Oh? Okay, die. Why'd you get back up? That's right. Making me feel really old doing this, saying you're really old doing this. Yeah. But it's like, because of my health conditions, like, my life kind of decided to hit the pause button when I was like 26. So I don't feel like I'm going to be 37 in a few months. It's very odd. Oh, why you were, like, on Twitch? Oh. Ah! Well, it's kind of a silver lining. And I think that was the ghost of Alessa crying in the bathroom. Which makes me even more sad. Yeah, well guess what? Like, one of the best streamers out there is Germa, and he's 35. Like, I think he's going to be 36 this year. You know, so it's like, there's nothing wrong with old people. Why am I calling us old? We're not old. We're older, but we're not old. But, like, that's true. Although, even if I were born later, I still don't think I would have started streaming because of, like, self-consciousness. Am I missing an item in here or something? I don't see anything. Anything? Whoops, hold on. Nothing useful in the desk drawer. Okay. Looking around. Just a map. Yeah, see, the whole VTuber thing is essentially what got me into streaming. Hi. I don't want to play with you, get off me. You son of a gun! Why? State you! But yeah, like, the digital avatars were like a godsend. Because, like, I wasn't able to do anything, most anything, while being at home. And I'm not really comfortable showing myself. But once, like, digital avatars became a thing, it was like, alright, I could do that. I was starting a family, and he was starting an empire, getting audit company, became really being a star on the internet, so yeah. Yeah. Opening this. Okay, I think I've gone everywhere. Oh lord, I need to look at the number of bullets I have. 40. Oh! 46 is not bad. Here you are. Okay, now die. Alright, Okay. Reset the fight. Hopefully the other two will be farther from the door. That is not fair. Stay down. Okay. Stay down. Yeah, you know what I mean. I tried to keep it PG. Reload. Oh, lord, I'm almost out of bullets. Distilled water, no reason to take it. Yet. If anything, my issue is I forgot the camera is on, and sometimes people see things I wish they wouldn't. Oh! Yes, hydrochloric acid. I will take that. Do nothing, no. Is that it, though? Or, like, no items, or... Alright. Why? And how? 3, 4, 5... Okay, die. I'll be digging for gold, for instance, and look over and see myself, be like, well, oh, that's... out there, great. Dum-dum. Hey! And here's the hand. Reload. Yeah, the only embarrassing thing that can happen with me is that I just open my mouth and people realize that I'm an idiot. That's a very nice wife you have. Oh yeah, honey, the worst thing that could happen is that you open your mouth and people find out you're an idiot. Oh, that's... Oh, boy. I guess that's a sign of true love, though, because, like, even when they say things like that, they stay with you anyway. It's like, they understand you perfectly, and they still like you. 2, 3, 4, 5. Okay, die? Library... Oh no, I think that said laboratory reserve. And it's locked. What about over here? Crap. I didn't want to go here. I didn't want to go here! Hey, Brandon! Hey, Brandon! Brandon. Brandon. Hey, look. Hey, Brandon. I found a picture of your mom. Your mom is probably wonderful, and I don't mean that at all, and I'm very sorry. Like the other day, she, loud and clear enough, where people heard her yell of me leaving steaks. Oh, oh! Yeah, I don't have to worry about that. Alright, I don't think I missed any items in here. So... where are you? That was a miss. This is Sparta. Okay. It's time to swing. This is so bad. Okay, will you die, please? And you die. Okay. This game is so freaking brutal! Oh, I have a lot more bullets than I thought I did. Oh, and there are more! Oof. Alright. And... I don't think there's anything else in here. It's borderline X-rated, depending on what my wife is doing. Just off cam. I have warned her about me getting TOS from something she wants to show, like... Oh... Oh... Your wife is just an agent of chaos. Oh dear. Alright. Now, what's in here? Oh, I know what's in here. Dumb jump scare, and also... just a cat. And that sucks. Nothing inside. And I really don't think there's anything else in here. Okay, so let's plan this through. We're gonna go to the music room. Actually, there's no reason to go to the music room. I can't actually do anything in the music room. Because I have to change the time. So, we're just gonna go back here. Whoa. Oh! Oh! Why? I was hitting run! Where are... I think I need two? There we go. Reload and equip. Okay. Oh, I think I can unlock this door. Yay. Crap. I haven't been to these rooms, so... I was! Not anymore! I've used 2 health drinks, but, like... Good lord, is this game Like, hard difficulty is hard. I've just realized. Alright, where are you? I hear you and I don't see you. Oh, it's just the baby. Sorry. And go boats, yes. Okay. I think I actually do need to check out that hall. Okay, so we're gonna run out here, avoid monsters. Okay, hall I think is just to my right, so unlock this door and go here. Lock is jammed, so perfect. Alright, so then we're gonna go back into this door. Oh, I looked over at my one live in my followers and saw you and said to myself, I should. Well, if that makes you dumb, then I'm pretty dumb too, because I've I've done things like, oh man, I wonder where my glasses are, and then realize, oh, I'm wearing my glasses right now. But yeah, that's... Oh, I should watch them. It's like your past self was like, don't worry, homie, I got you. Okay, Alright. Let's put that golden sun in. Use... Ta-da! Exactly. And I already know the solution to it because I played this already, not yesterday. Now let me consult my memory, quote unquote. Okay, I remember everything. I need you to get minimized. Minimized. Here we are. So when I get to this roof of the elementary school, I gotta do something. Yes! That's so I have a list of that. I just had to look and make sure I knew what the heck I was gonna do. Okay, so I got that. And the clock should be at a different time now. Yep. So it was at 10. Now it's at noon. It is in the Otherworld school. Let's see. Alright, so we're gonna go back the way we came. Also, I'm really curious at how many bullets I have. Whoa. Okay, 92 bullets. I'm in a lot better shape than I thought I was. Okay, so let's save. Alright, walking over here. We're gonna go up these stairs. Shut up, kid. Oh! Okay, you're dead. Why did you say that? That's like the meanest thing. See you, kid. All right. Okay. Right. Who needs to die? No, because it won't even stagger them. Reload. Okay. Whoops, I hit the wrong button there. Whew. Okay. Alright, I was in the locker room. We're gonna unlock this door. Nope, we're not gonna unlock this door. We're just gonna walk over here. And we have to play the keys that don't work, and we have to play them in order. Let's just make sure that I've triggered everything. Good, blah, 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 blah. Are there any items in here for kicks and giggles? Doesn't look like it. Okay. Now, where is my notebook? There is my notebook. Okay, opening up to the page of the piano puzzle. Where did I put the piano puzzle? Oh, I'm looking right at it. Yes, okay, there's the drawing of the piano that I made. I think... Great, I didn't really keep good track of notes. First flew over the greedy pelican, eager for the reward. White's flailing. So the pelican is the first dead key. And now I gotta find my pen! When I'm out of... I wasn't out of range. I had my notepad in front of me like this. And I'm back! Now I'm out of range, though. Okay. Oh, absolutely. So with my health, I have to be reclining on my back so that I stay awake. So I'm at a really awkward angle. So the camera often thinks that my eyes are closed, when really they're open. But no, it's fine. It is fine. Like, I found a lot of silver linings to how my life's gone. So black key, and then 3 more black keys. Pop it open the keyboard. Check that piano. Yep, so then 3 more black keys. Black. So then these are the divisions of the white keys. Okay. Now, for my notes, it looks like the dead ones are that one, the ones straddling a black one, and this black key right here, and this black key right here. Okay. So that gives the 5 keys. Good. 1, 2, 3. 3 birds are white, which means 2 are black. Yeah, it's essentially. Like, my back is, like, my head is propped up, so it's almost like a 90-degree angle, but yeah. It's weird. Okay. First flew the greedy pelican, eager for the reward, white wings flailing. So the pelican is the D key, if I understand correctly. And Brandon, if you make a PP-related joke, I'll be very proud of you. Holy crap, what the heck? Brandon, are you okay? Brandon? What? Oh. Yeah. I treat my mods well, don't I? Here, like, have a huge thing screwing with you. Okay, Brandon, what the heck was that? Yeah, what was going on with all the random, like, blabs on the keyboard? What happened? Uh, hold on here. Also, are you out of points, Brandon? Oh, never do that again. I just realized I probably need to do an input, uh... I need to, like, set the setting in chat so that people can't just, like, spam characters. Ooh, what is it? Oh. But yeah. I don't have channel points, but take your mouse and scroll it over, wait. Hey, Brandon? How do you redeem points? I've just realized I'm not really sure how Streamlabs does it for people who don't have Streamlabs, who are just watching the stream. Do you just mouse over the screen and then a little button appears that you can click? Because I think that's how that's how it works, but I'm not
Hi,
sure.
thanks for checking in. I'm still a piece of garbage.
Brain. X has stopped working. Do you wish to wait?
Ah, see, that's where Streamlabs OBS is super nice. it has its own extension that blah 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 blah. My mouth can't work. It has its own extension so that it has a loyalty program that gets built in with your stream. So it's not channel points, but it operates like channel points, but it's specifically provided by Streamlabs itself. So if you take your mouse and you mouse over the screen, you should see a button that you can click that will probably have like your Twitch profile picture. And if you click on it, then it'll say, do you want to redeem your points? And the points in this case are pencils. That's the name I gave for the loyalty rewards points. Okay. Now... Okay, so I just read the pelican thing. Then came a dove, flying beyond the pelican as far as he could. The dove is a white key. I'm guessing the dove is this one. Brandon, stop it! Okay. Dove. A swan glides in to find a peaceful spot next to another bird. Oh, well, it's the only other white key, so there's the swan. Swan. Finally out comes a crow, coming quickly to a stop, yawning and then napping. So then a crow is right there, which means the raven is right there. Alright. So, whoops. Oh, I hit the cancel button. Does this mean anything? Check piano. Yes. Okay. Brandon, what did you do? Yeah, we're all levels of scuffed here. Brandon is a brand new mod, and like he's as new to modding as I am to streaming, so we're still trying to figure everything out. And I keep hitting my mic. I hate that. Essentially, yeah. He also is an agent of chaos. Like Brandon, would you say that it's an accurate representation of yourself? I mean, if he wants that. Well, you guys don't have to do anything. Like, it's... That is a good poop joke, by the way. But it's like, you don't... Like, being a mod on this channel, is like... Yeah, it's like being a cop in heaven. You know? Who are you telling to just be cool? You're the one that was spamming the chat with, like, just 3-letter strings. Yeah, okay. Let me actually solve this puzzle. And of course, I don't remember what... Okay, the pellet... Like, why did I put... Punch me in the face. Pelican, the next one was a dove. And then a raven. So the raven is good old number 3. Swan is number 4. Crow is number 5. Okay. Alright, so... Oh. I have it paused. It's not paused anymore. Okay. So... Pelican... Dove... Raven... Swan... Crow. I know that works for Silent Hill 3. Because I think that's the... Is that the unlock to get Donald in his underwear? Yeah. And we got the silver medallion. Okay. Well, let's put a pin in that for now. Yeah. I mean... If I knew how to draw, maybe? And if I had money. But I can't, I have no money, and I have no art skills. So, like, things that actually require artistic skill. Well, I think Streamlabs offers emotes too. Get money. I'm trying! Oh, so you can hear Douglas sigh, like, fine. Yeah, I can't wait till I get to Silent Hill 3. I think it's my favorite out of all of them. Silent Hill 2 is probably the scariest. Yeah. Okay. I just realized I need to use the restroom, so, I'll take us to our be right back screen, and I will be right back. So, give me a sec. Okay, I'm back. Hold on one sec. I need to get a drink of water. Also, Brandon, you're not my dad. And if I needed to wipe, I'd still wipe. What reward? Wait, did you redeem something? Does such a thing exist? Also, I'll take another drink of water then. That's what I'm forgetting. I realized I was actually gonna make a redeem where, Wait, did I make a hydrate redeem? Wait, you're telling me I actually made a hydrate redeem? Oh. Okay.
Oh, hi. Thanks for checking in. I'm still a piece of garbage.
Drink water.
Drink water. Okay, I'm drinking water. Ah, and that's actually some good water. I like this. Hmm.
Oh, hi. Thanks for checking in. I'm still a piece of garbage.
Drink water.
I already did. That's another thing, is I need to find a way to prevent
Oh, hi. Thanks for checking in. I'm still a piece of garbage.
reward spam.
Drink water.
Okay. Let me get down so my camera can actually see me. I'm sorry, kitty. Okay, there we go. Oh. I know. I'm actually planning to go for one more hour. I'm feeling pretty good. So, let's see if I can actually hit 5 hours. Okay. Okay, good. I'm actually in the camera. Things are okay. Good, good, good. Alright. I have the silver medallion, file, command. I'm just gonna save in case, like, things crash. Good. I have not been to the 3rd floor. That's the roof. Okay. I haven't been to the library either. I didn't even see that. Okay. Yeah, I am so happy that emulation is a thing. Brandon, no! Okay. do I need to go down to the boiler room? Actually, I think the boiler room is where you get the hammer. Right? I think? Okay. Oh no, what is that? Well, I can see that. Yeah, but like who is that, like a particular streamer? That has to be. Oh, so that's the STH. Gotcha. I've never heard of them. Uh-oh. Alright, fine. Die. Hello, little kid. Alright. So, let's just check to make sure this door... Crap. Someone's in here, I know it. I hear you. Oh, dog covers of songs. Okay, that's very clever. Alright, there's a monster here. Oh! Oh! Oh, wow! No special books here. I have never been here. No special books here. Why are there a bunch of little baby ghosts in the library, though? What particular detail am I missing? If it's on cover seal. Oh. Is there anything? Really? Huh. No useful books. No useful books. Yeah, I don't think I've ever been in this room before. That's interesting. Oh, and now I can go to the Library Reserve. Right. Now, is there a monster in here? That's another question. Because I can't see him. Yep! Hello! What did I miss? Alright, anything there? Nope, no useful books. Got it. Anything here? Nothing special, no books here. Okay. Is this room seriously... I've never had to. Guess... Oh, okay. It's in the other world. Click on it! Click on the box. I think... Yeah, but if you click on the box... Oh. Well, just take your mouse cursor and... Or are you making a joke? I don't know if you're being serious or not. Alright. Okay, so I got that unlocked. Let's see if I have 5 bullets. Nope. Okay. Good night. Take your mouse cursor and move it off of the screen, so like onto chat, and then move it back onto the screen. If the if the box pops up again, that's the Streamlabs loyalty points button. So you click on that, and that's how you can redeem anything. Alright, I think I went into those rooms already. Yeah, I did. Okay. And I need to get to the roof. Alright, that's another thing that I just realized. Okay. So it's in this hallway that I gotta go, if I want to go to the roof. It's eerily quiet. I don't like that. Okay. We're gonna unlock that door. And I... Oh! That is a reward drop. So the system that's like channel points, it gives you... Oh, okay, so I guess I can't open this door until the, Otherworld. I don't think you need to click on the treasure boxes. But they're just like random drops of channel points. So it's like, instead of just getting the normal allotted loyalty point amount, you get a little bonus. I'm sorry, you didn't raise your hand. I don't recognize your request. Also, should I... I'm gonna go to the basement before I place this medallion. Okay. Alright, well, just to show that I'm very nice, like, I put, cool little donation sounds. So, like, here's my bits one. Yeah. Brandon's a giant, Initial D fan, so I was like, here you go, man. I know what you like. So that's that. Here, I'll even play for you again. I hope so, otherwise I'd have to ban you. That's a joke. Oh my gosh, yeah, I remember, blah blah, wow, my mouth decided to explode. Yeah, I remember that. That's how like, Dragon Ball Z. I didn't even know what anime was, but I love that show. Alright, okay, so we're going to the basement. Take that. Oh! I hate this! I hate this! I hate this, and I'm leaving! This is so terrible. Swing away. Well, I died. That's what I get for trying to run. Ugh. Yeah. Uh-oh. No. I did remember to do something, though, so let's say... Save options, low state. Let's see what happens. Boom. Okay. Now where am I? Whoops. Dang it. There. Now, where am I? How are things? Okay, so I just solved the piano puzzle. Haven't really bothered to go to the roof, because there's not really any reason to. There's no reason to go to the library reserve, because there's just a monster there, there's no item. And on the first floor, there's nothing really there either. Okay. Alright, so unlock. Never mind, I did not unlock that. Okay. Just making sure I know where I am. Okay, good, good, good. Oh. Turn around! Okay, die. Okay. Whew. Alright. There's a little baby. Sorry. Okay. Library. This place is safe, because it just has those little kids. Okay. So we will take that. Thank you. Sorry, kids. Alright. Alright, fine. I guess I'll do this. There's a little monster kid here, though. Alright. Unlock the door. Get out. Five. Dead. Why did you... Disobedient little rat. Okay. So that order of events went okay. So we're gonna advance the save state. Oh. See, we're fine. We're fine. We're fine. Everything's fine. We're good. We're fine. Totally fine. Okay. We'll run down here, we'll unlock the door, and then we'll go back to the first floor. I did not want to do that. Okay. Okay, so hang a right, run this way, down the stairs. It's quiet. Okay. I guess there's no reason to not just run down the hallway, since it's so quiet. Okay. Alright, where are they? Alright. This is getting a little dicey. Stay down. And stay down. Okay, good. Good. Where's the other one? Oh, never mind, there was only two, and it just took two kicks to kill. Oh. Okay, crisis averted. Because this is where I died. Oh. Very good. See, we're fine. We didn't lose that much time, we're fine. Everything's fine, we're okay. Alright. Okay, got that. Nope. See you, kids. Very quiet down here. Can't go to that door. What about this? Whoa, that, like, ugly... Alright, I can't turn this on yet. Wonder what... Are these interactable? Nope. Nothing appears to happen. Yeah, it's not going to happen until I advance the time. Yeah, so then the only thing left to do is put in this silver talisman thing. Oh! Yeah, no. Okay, so I'm gonna put down a save state. Boom. Okay. And now it's time for the other school. Reload. Only 39 bullets. Lovely. Okay, now here. Silver Moon. Cool. Okay. Now it's time to go through the clock. What? Oh, so now I have to go to the boiler room. Okay. Yes, because that one poem said something about a fire. Yeah. Okay. Alright. There are probably going to be demon children down here. Nope, never mind. Ah, yep. Alright. Yep, and that was the lizard. Okay. Monsters. No. Lovely. Okay. So the clock tower is ready for us to go through, probably. Command. Save. Hopefully no monsters. I hear you. Oh, and no monsters. Good. So then we're gonna save again. You can't save too many times. That's impossible. Infirmary. Okay. Right. Boom, boom. Okay, no turning back. Are there any useful items on the ground? I wonder if these bottles are supposed to represent, like, drug bottles. Specifically, the drug that the cult was dealing in. Huh. Okay. Now we're definitely going to save here. And open the door. I think they're going to be monsters.
Where am I?
I don't know.
Have I been here before?
Kind of.
I don't remember this being here before.
A lot of stuff you don't remember. Alright. Okay. I guess there aren't any items. I just need to go get the key, which is there. Okay. Saving again, because I know I'm probably going to get screwed over when I open this door. Never mind. I'm going to get screwed over when I open this one. Yep. Yep. Nope! Why? Why? Okay, so dead. And dead. Oh. That could actually have gone worse. Alright. I can live with that. Is it going to say that I have a map? Yes. Oh, good. Alright. Now, I'm pretty sure there's a fight in here. Shows how much I know of the game. I would gladly take those bullets. And this. Lovely. I guess we'll try the storage room. And here's the ball that we need to plug up stuff. Got it. Headless dolls. Nothing unusual. Okay. So that was the storage room. Oh, and I just ran past a door. Ah, great, it's a million. Wow, why are there so many? Okay. Where's the other one? There you are. Don't tell me this room is empty. Alright, is this door even gonna work? It does. Also, there's no monsters. Okay. Save, because I'm paranoid. Cool. Wait, I'm right in front of the card. Come on. Thank you. Is there anything? Nope. So let's go to the other classroom with monsters. You! Why? Alright, Brandon. Thank you for hanging out. Also, glad that we could talk about lines. Hopefully they make more sense now. I'll be streaming tomorrow, so if you can make it, fantastic. If not, there will still be a VOD. So, good night. Why are there so many? That is so unlucky. This makes me wonder... Also, what the heck? Oh, cool. Do I really not get the rock drill until, like, after the elementary school? Normal mode. It is found in the Orage Bridge control room. Yep, so I have to go through the entire elementary school with a lot of close quarters combat until I can get the rock drill. The Hell gas station on Block Street. That does sucketh. You know? Okay. I'm gonna call it here. Since I'd have to, like, start from a last save anyway. So we'll pick this up tomorrow. Let me... That's the wrong button. Let me hop over here. Okay. So... Pretty good stream. Oh my gosh. Oh my gosh, my brain. So pretty fun stream tonight. Oh. Not as scuffed as normal. I'll keep working on getting things better and better. Hope to see you guys tomorrow. If anybody out there needs free math tutoring, that's what I'm here for. Just drop questions in chat. And if you're some weirdo who's watching this on YouTube, yeah, just tune in and ask math questions for free. Until then, I'll see you guys tomorrow, 3 p.m. Pacific time, and goodbye.